In this video, I will show you how to solve systems of equations by graphing. Now the key is to have both of your equations written with y by itself. Y equals this, y equals that. I'm really just going to make this one slight modification. So we have y equals 0.5x plus 1. I'm going to write that as y equals 1/2 x plus 1. Other than that, I've just recopied these two equations down here. Now, let's start with the blue equation. Y equals 2x minus 5. The negative 5 is the y-intercept. So 1, 2, 3, 4, 5. So here's the minus 5. The slope of 2 you can think of as 2 over 1. So that's up 2, right 1. And you'll do that repeatedly. Up 2, right 1, up 2, right 1, etc., etc. So here we have the graph of that line. And we will do the same thing with the red equation. The 1 is the y-intercept, so I'll put my first dot at 1 on the y-axis. Slope of 1/2 means that we are rise over run, so that's up 1, right 2. So if I go up 1, right 2, up 1, right 2, up 1, right 2. And I could repeat the pattern going to the left by going down 1, left 2, etc. So here we have the graph of this line. Okay, the solution will be the intersection of these two lines, which we can see is right here at 4, 3. So the solution is 4, 3. All right, let's go on to number 2. So this time, neither one of these equations quite has y by itself. But if I were to take this first equation and divide everything by 3, then that will give me y equals 4 over 3x plus 2. Now if I were to take this second equation and divide everything by 2, then that would give me y is equal to, now this x over 2 is the same thing as 1/2 x. So y is equal to 1/2 x minus 1/2. Okay, so that'll be a little bit weird, but I think we can deal with it. Alright, having a 1/2 for a y-intercept is not ideal for solving by graphing, but let's make it work, people. So let's see, starting with the blue equation, the y-intercept is 2, so there's my 2. Now the slope is 4 over 3, so that's up 4, right 3. And let's continue this to the left by going down 4, left 3. Okay, and I'm going to try to be a little bit more precise with my line this time. Because of the decimals involved, I'm going to use my line tool, so I'm cheating a little bit. Okay, so there I've graphed that line. So now let's try the red one. So the y-intercept is negative 1/2, so that's down half a square, so that'll be right here in the middle. So the slope is 1/2, so that's rise over run, up 1, right 2. So if I go up 1, right 2, up 1, right 2, up 1, right 2. I can continue the pattern to the left by going down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. Okay, so again, I'm going to draw this line as precisely as I can by using my line tool. Okay, so the point of intersection seems to be right here at -3, comma, -2. Alright, so that will be the solution for problem number 2. Alright, let's do one more. Alright, we've got x equals 5, so fine, I'll keep that in mind. But the second equation, in order to get y by itself, I would have to subtract 4x from both sides. So far that's going to give me 5y is equal to -4x plus 20. And then I would need to divide everything by 5 to get y by itself. Okay, so in the end, I'm going to have y equals -4/5 x plus 4. 20 divided by 5 is 4. Alright, so that's the second equation. Meanwhile, the first equation was x equals 5. Now, a long time ago we memorized that if I have y equals 5, this would be a horizontal line like this. 2, 3, 4, 5. So this is 5. So this is what the line y equals 5 would look like. It would be a horizontal line at 5. Alright, on the other hand, x equals 5 is a vertical line at 5. So x equals 5 is going to look like this. Alright, it's a vertical line at 5. So that's my first line. So my second line, I have a y-intercept of 4. So 1, 2, 3, 4. And then a slope of -4 over 5 means down 4, right 5. So, oh, and by the way, this negative, I always put the negative sign in the numerator. Okay, so down 4, right 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, and that is enough. Because we can see that the point of intersection is right here at 5, 0. So that is the solution to problem number 3. And that's how you solve a system of equations by graphing.